In the last video, we discussed the SI supplementary unit of plane angle, that is radian, and its relation with the commonly used unit degree. Now we are going to discuss solid angle, physical quantity solid angle, and its supplementary unit in SI. It is called steradian. Imagine a sphere, solid sphere in 3 dimensions. This is not a plane circle, it is a solid sphere having center O. Let its radius be R. Take an area on the surface of the sphere. Let that area be A. Then you get somewhat cone-like shape here. This is called the solid angle, represented by omega. Solid angle subtended at the center of the sphere by the area A on the surface of the sphere. What is this? Solid angle. What is omega? It is a solid angle subtended at the center of the sphere by this area A, which is on the surface of the sphere. This solid angle is equal to the area A upon R squared. Solid angle symbol is omega. So what do you have? Omega is equal to A upon R squared. Steradian. Represented by SR. So you understood what is solid angle? It is the solid angle subtended at the center of a sphere by an area A on the surface of the sphere is given by the ratio of the area to the square of the radius. What will be the total solid angle subtended at the center of the sphere by the entire surface? What will that be? Let me take it to the entire surface, that means this whole entire surface. What is the total surface area of the sphere? 4 pi r squared divided by r squared, which is equal to 4 pi steradian. So solid angle is understood, and its solid angle and its SI supplementary unit, steradian. Now let's go ahead to measure how to measure distances. We will discuss the units of SI, all 7 fundamental units and 2 supplementary units. Now let us discuss how to measure length. Measuring length can be done by direct method. Direct method of measuring length is using a scale or a tape to measure the length of a room or length of a table, etc. You can use scale or tape. That is called direct method. Whereas we have indirect methods also to measure distances. For example, you want to measure the height of a mountain. How can you do that? We are going to make use of indirect method. That means the knowledge you have acquired in 10th standard while studying heights and distances. I am going to do part of it, you are going to complete it. Suppose this is a mountain. Let me call it AB. its height is h, which you want to measure. So from a faraway distance, you measure the angle of elevation of the top of a mountain, top of the mountain. Angle of elevation and angle of depression you learnt in 10th standard. Let this angle of elevation be θ1. Now move towards the mountain by a known distance. That means you are knowing this distance. X, CD is X. Now again measure the angle of elevation. θ2. Let this distance be Y. Now this is going to ACB is going to be a right angle triangle. What is AB upon BC? Then not tan θ1. Tan θ1. Opposite upon adjacent is tan θ1. Now, what is this AB? It is H. What is BC? It is BD plus CD. What is that? X plus Y is equal to tan θ1. For this equation 1. Wait, let us cross multiply this. What is H equal to? It is X plus Y into tan θ1. Putting this equation 1. This is from which triangle? We got triangle ACB. Now they write the triangle ADB. This AB upon BD will be tan θ2. But what is this AB? AB is H, BD is Y. From here I am having H is equal to Y tan θ2. Put this equation 2. Put this equation 2. Now from equations 1 and 2, LHSs are same. Therefore RHS should also be same. Therefore what do we get? From 1 and 2 we get X plus Y into tan θ1 is equal to Y tan θ2. Now opening this bracket and rearranging. If I open this bracket, what do I get? X tan θ1 plus Y tan θ1 is equal to Y tan θ2. Now rearranging this and taking common Y, what do I get? Y equal to X tan θ1 upon tan θ2 minus tan θ1. Let me put this equation 3. I got the value of Y. Now substituting this value of Y in equation 2, I can get the value of H, which is the height of the mountain. I'm erasing this part. 3 in 2. What do I get? H is equal to, in place of this y, I'm going to substitute this value. Then what do I get? X tan theta 1 upon tan theta 2 minus tan theta 1, that is y, into tan theta 2. All these terms can be measured. You can measure the distance CD, that is x. Angle of elevations theta 1 and theta 2 can be measured. Substituting these values in this equation, you can calculate the height of the mountain by an indirect method. You are not directly measuring the height of the mountain.